Hello everyone, let's learn today interior of the cranium. So once we cut the vault, the interior of the cranium we studied into interior of the vault and interior of the base of the skull. So in this video we are going to discuss about interior of the vault and part of the interior of base of the skull. So now we know this is a cut vault and you can see the cut margin and interior. It is irregular, it has got vascular markings and it has got some sutures, and the sutures are similar with the sutures what we have discussed in the norma verticalis. So this is the interior of the coronal suture and this is interior of the sagittal suture. Part of the lambdoid suture is also visible. So in the vault we can see interior of part of frontal bone, interior of the parietal bones and interior of part of the squamous part of the occipital bone. So if you join the vault, you can see this is frontal bone, these two are parietal bones, and this is occipital bone. So these many bones are visible from inside, and if you see the frontal bone separately, the interior of the vault will show a frontal crest. Let me show you. So this is frontal bone, and if you see its inner aspect in the midline, it shows a midline sharp frontal crest. You can see over here, and that provides attachment to falx cerebri. Above it splits to enclose the anteriormost part of the sagittal sinus. So over here you can see this is frontal crest, and that is continuous with the interior of the vault. You can see over here in the vault. So the same split frontal crest will be over here, and that is continuous behind as sagittal sulcus. You can see over here the sulcus. Now this sulcus will lodge superior sagittal sinus, and the sulcus will become broad from before backward. The leaves of the sulcus will provide attachment to falx cerebri. On either side of this sulcus, you can see over here, you'll see certain depressions. Now these depressions are more marked in elderly skulls, and they are produced because of arachnoid villi and arachnoid granulations. These depressions are termed as granular fovea. Now we know this is coronal suture, and approximately 1 centimeter behind you will see markings, vascular markings, and this initial vascular marking is produced by middle meningeal vessels, and then it divides into anterior and posterior branches. So many such vascular markings related to the branches of middle meningeal vessels, particularly of veins, they are produced in the inner table of the vault. You can see over here, and the middle meningeal vessels will come out through foramen spinosum. So if you see the portion of base of the skull which is related to that vascular markings, you will end up that vascular marking to the foramen spinosum. So here somewhere you will get foramen spinosum, and you can see the continuity of that vascular marking. So here it is lodged by middle meningeal vessel. So that portion we'll discuss in the interior of base of the skull, and you can see over here these vascular markings will continue in the vault. So in the vault we'll see many vascular markings, and over here you can see this is sagittal suture. This is a portion of lambdoid suture, and over here will be formation of lambda, and approximately 1 to 1.5 inch in front of that you will see two parietal foramina, which will allow passage of emissary vein, and that connects scalp to the suprasagittal sinus. Now next is interior of the base of the skull. Naturally it is subdivided into three fossas from before backward. It is termed as anterior cranial fossa, middle cranial fossa, and posterior cranial fossa. So today in this video we are going to discuss about the anterior cranial fossa. Now you can see over here it is formed by three bones, on either side by frontal bone, posteriorly by sphenoid, and in the center the portion is contributed by ethmoid. Now let me show you the same in separate bones. So this is frontal bone, and if you see it from inside, this you can see these two bones. These are termed as orbital plate of frontal bone because they are forming roof of the bony orbit, portion of roof of the bony orbit. So these two will contribute to form part of the lateral aspect of anterior cranial fossa, and in between these two you can see there is a gap, there is a notch, and that is filled by ethmoid. Let me join the ethmoid. So this is ethmoid, and in the center you can see from upper part you can see a cribriform plate of ethmoid with multiple foramina, and that will allow passage for the olfactory nerve. So if we put this into that notch, that portion of the ethmoid will contribute to form anterior cranial fossa like this. Okay, now posterior portion of the anterior cranial fossa will be contributed by lacer wing and body of the sphenoid. Now this is sphenoid, and in the center is a body, and on either side from above you can see there are two lacer wings. So if we join this together, so in the center ethmoid is connected to the body of sphenoid, and the orbital plate of frontal bone will connect with the lacer wing of sphenoid like this to complete the anterior cranial fossa. So this is how the articulation will take place, and together these three will form anterior cranial fossa. So now we know three bones are contributing, and let's see the bony features. So in the center this portion belongs to the ethmoid, and in the center part you can see there is a tooth-like bony spicule. This is termed as crista galli, and this will provide attachment to falx cerebri, and that attachment of falx cerebri will continue with the frontal crest. On either side of crista galli, as I told you, there is a cribriform plate of ethmoid with multiple foramina. So approximately 15 to 20 olfactory nerves, they pass through this foramina from the posterior superior part of nasal cavity, from the olfactory epithelium. So if you see it from piriform aperture of the nose, in the center you can see perpendicular plate of the ethmoid, and on either side of that you can clearly appreciate cribriform plate of ethmoid. Let me bring it closer. Now over here in that portion, the nasal mucosa is converted into olfactory epithelium, and that from that portion 15 to 20 olfactory nerves will traverse cribriform plate of ethmoid, and they will end up into olfactory bulbs. Now these olfactory bulbs are lying on the cribriform plate of ethmoid over here. Now in front, the ethmoid will join with the frontal bone, and there forms a foramen. You can see over here. This is termed as foramen cecum. Generally it is a blind foramen, but sometimes it may connect the superior sagittal sinus to the nasal cavity through a vein. Now posteriorly ethmoid articulates with part of body of sphenoid, and that portion of body of sphenoid is termed as jugum sphenoidale. Now at the posterolateral aspect of their junction, over here you can see this is cribriform plate of ethmoid and this is jugum sphenoidale. So at its posterolateral end over here there are two canals which are termed as posterior ethmoidal canals, which will allow passage of posterior ethmoidal vessels. So the same canal are observed in the medial wall of the orbit. Let me throw some light and let me show you that portion. So over here you can see this is the bony orbit, and on the medial wall you can clearly appreciate two foramina. Over here you can see this will be the anterior ethmoidal and this will be the posterior ethmoidal foramina. So over here I will show you again. You can clearly make out these two foramina. Now the posterior one will open at the junction of ethmoid with the jugum sphenoidale over here, and that will allow passage of posterior ethmoidal vessels only. Remember, the posterior ethmoidal now will terminate very earlier. Now laterally, this ethmoid will articulate with orbital plate of frontal. That you can clearly see. These two are orbital plate of frontal bones, and on its lateral aspect, similar like the posterior ethmoidal canal over here, you will see anterior ethmoidal canal. So let me show you again. So here you can clearly make out anterior ethmoidal foramen, and that opens over here in the form of anterior ethmoidal canal somewhere over here, and that allows passage of anterior ethmoidal nerve and vessels. So both these structures will come out from it, whereas posterior ethmoidal canal will allow passage of only posterior ethmoidal vessels. Now next is on either side you can see these two are the orbital plate of frontal bone, and they are forming, as we have discussed, they are forming roof of the bony orbit, and In the interior, they are showing multiple irregular markings. These are produced by reciprocal sulci and gyri of the orbital surface of frontal lobe. And its medial margin, as we have discussed, it is connected to the cribriform plate of ethmoid, and that portion over here near the medial margin, this portion is covering the labyrinth of the ethmoid. Let me join these two again. So here this are the labyrinths to another side of the cribriform plate of ethmoid, and that is partially overlapped by the medial margin of orbital plate of frontal bone, like this. Now posteriormost bone is the sphenoid, and you can see these two are lesser wing of sphenoid, and their sharp posterior margin limits the posterior boundary of anterior cranial fossa. Medially, these two sharp posterior margins, they form a bony spicule. Over here you can see this is termed as anterior clinoid process, which are continuous with body of sphenoid medially. And over here you can see there is a formation of a sulcus, which is part and parcel of middle cranial fossa. This is termed as sulcus chiasmaticus. So its anterior margin, or you can say posterior margin of jugum sphenoidale, over here, this is the posterior limit of anterior cranial fossa. So this is how the anterior cranial fossa is limited or bounded. Now let me show you the lesser wing of sphenoid. So this is sphenoid, and these two are lesser wing of sphenoid. And as I mentioned, the posterior sharp margin forms the posterior limit of anterior cranial fossa, which ends up into anterior clinoid process. Now this anterior clinoid processes will provide attachment to free margin of tentorium cerebelli. Let me show you the same in the diagram. So in this diagram you can make out that this blue color structure is the tentorium cerebelli. Now it has got two margin. This is the attached margin, which is attached to the petrous temporal bone, and this U-shaped is the free margin. So here you can see anteriorly it is attached to anterior clinoid process, and then it is free and it forms this U shape through which, through this gap, there passes brainstem from the middle cranial fossa to the posterior cranial fossa. Now this is the attached margin of tentorium cerebelli. So the anterior clinoid processes will provide attachment to free margin of tentorium cerebelli. So the lesser wing of sphenoid, anteriorly it articulates with the orbital plate of frontal bone. Medially it is continuous with jugum sphenoidale. Posteriorly it forms sharp free margin which lodges stem of lateral sulcus, and that limits the boundary of anterior cranial fossa. Here it forms anterior clinoid process, and below it splits, you can see over here, to form two roots, anterior and posterior roots, and these two roots will fuse to the body of sphenoid, forming a canal in between, and that is termed as optic canal. So let me show you the same in separate bone. So this is lesser wing of sphenoid, this is anterior clinoid process, and you can see over here there is a formation of optic canal. So same thing you can see from in front. Now medial to the lesser wing of sphenoid, you can see this portion of body of sphenoid is termed as jugum sphenoidale. Anteriorly it is connected to the ethmoid, posteriorly it is free, and that forms posterior limit of anterior cranial fossa, and below it is related to sphenoidal air sinuses. Let me show you the same in separate bone. So this is jugum sphenoidale, this is sulcus chiasmaticus, and over here will be ethmoid, and below you can see within the body there lies two sinuses which are termed as sphenoidal air sinuses. So the jugum sphenoidale covers part of sphenoidal air sinuses. So this is about anterior cranial fossa. In consecutive videos, the middle and posterior cranial fossa are explained. Hope you understood well. Thanks for watching.